Okay, so the first 6 problems of 5.2 practice are looking at using the properties of rational exponents to simplify. So what that means is you're looking for all the properties you know that says when you have like bases, if you're multiplying, like in number 3, you're going to add the exponents. If you are dividing, like in number 1, and you have the same base, then you can subtract the exponents. If you have a power raised to a power, like in 2, I have this power, 9 to the 4th power, raised to the negative 1/4. So when you have a power raised to a power, you multiply the exponents. Okay, now we'll get into some down here where they aren't the same bases, so we're going to have to work on getting them to be the same base. Okay, so let's just use our properties. I'll go through making sure you know how to use your calculators to do the fractional part of adding and subtracting and multiplying. So number 1 says 2 to the 3/5 divided by 2 to the 8/5. So if you're dividing, property says you keep the base, you have to subtract the exponent. So we have to take 3/5 minus 8/5. So on your calculator, all you're going to do is take 3 divided by 5, that's 3/5. You're going to subtract 8 divided by 5. So 3/5 minus 8/5, I get negative 1. So that's my exponent. It's 2 to the negative 1st power. We kept the base. On our calculators, we subtracted the exponents. Now, we do know that if you have a negative exponent, you can't leave it. You have to change it to kind of flip it to the denominator. So 2 to the negative 1st is 1 over 2 to the 1st. So any negative exponent in your answer, you have to flip down into the denominator. All right, so let's look at 2. 2, these are different bases, so I can't do anything with these, and I can't get them to be the same base. So all I can do is take a power raised to a power. So again, on my calculator, I need to take 4 times negative 1 divided by 4. So I'm taking a power to a power, so I'm multiplying the exponents. Hit enter, and I get negative 9, or negative 1. So that's 9 to the negative 1st power. And then I do the same thing down here, but notice I still have 4 times negative 1/4, so that's going to be 14 to the negative 1st power. And so again, I have 2 different negative exponents. It's always the exponent you're looking at. If the exponent is negative, you have to flip them. So the 14 has to go up, the 9 has to come down. So it's going to be 14 to the 1st when I move that up, over 9 to the 1st when I move that down. So 14/9. Now this is the work I'd expect to see on your paper. Okay, so you do need to make sure you're using your calculator, but only to help you multiply fractions. All right, so number 3, we have 21 to the 3/5 times 21 to the negative 4/5. Now you have a power to a power, so you could take each of these to the negative 1/2, or what I would probably do first, since these are the same base, is I would multiply them first. So the rule says when multiplying, I keep the base. I need to add the exponents. So 3/5 plus a negative 4/5. So 3 divided by 5 minus, because it's a negative, 4 divided by 5. So I'm really adding a negative. So 3/5 plus a negative 4/5. I get negative 0.2, but I need to make sure what that is a fraction. So make sure you know that to get it to a fraction, you go to this math button right here. When you hit the math button, you're going to convert to frac. You're going to convert to a fraction. So you're taking your answer, converting it to a fraction, you get negative 1/5. And the reason you want to do that is later when you have to change this to a radical, like the 5th root of 21 to the negative 1st, you'll know what that is. The negative 0.2, you won't know that. All right, so that's what I get when I multiply. And now I have a power to a power. So now I need to multiply those exponents. So I keep the base. I need to take negative 1/5, which is already right here, times negative 1/2. So I just took my answer, negative 1/5, multiplied it by negative 1/2. And I get 1/10. So it's 21 to the 1/10 power. So again, all you're using your calculator for is adding these fractions together. And then you have to do math, convert to fraction. And then here we had to multiply the fractions together. Now, really, you could do this without calculators. When you're adding fractions, you just have a common denominator. It makes sense. You're going to get negative 1/5. When you're multiplying, you just multiply straight across, so you get 1 over 10. But you definitely can use your calculator if you feel like you want to make sure you've got that. All right, so let's look at 4. 4, again, same bases, so I would add those exponents together. So I'm going to keep the base. I'm going to add the exponents, so I'm going to take negative 6/5. And we're going to add 4/5. I get negative 0.4. I hit math, convert to fraction. I get negative 2/5. And again, if you look at that, you're just adding the like terms, so you get negative 2/5. Makes sense? And now I have a power to a power, so I multiply. So negative 2/5 times a negative 1. A negative times a negative is a positive, or you can do it on your calculator if you need to. So you're going to get 3 to the 2/5 power. And again, in these directions, it just said simplify the expression, so we don't have to put that in radical. Now, if it was something like in numbers 3 or 4, and they told you to put it back in radical form, let's just make sure you could do that. This would be the 5th root of 3 squared, or the 5th root of 9, if they asked you to put it back in radical form. But they didn't. They just said you could simplify it. Okay, so let's talk about 5. So if you look at 5, these are not like bases. So we can't do anything if they're not like bases. So to get them to be the same base, so this is kind of the hard one of all of these, we need to change this to a base of 2. 8 is 2 to the 3rd power. So I'm going to change the 8, and 4 is 2 squared. So to get them to be the same base, I'm going to leave the 2 to the 3/4 alone. I'm going to write 8 as 2 to the 3rd power. Now, everybody should realize I didn't change anything. I still have 2 to the 3rd, which is 8 raised to the 3/4. The only reason I changed it is now I have a base of 2. Same thing in the denominator. 4 is 2 squared, and that was raised to the 3/4 power. All right, now I have bases of 2. So let's start doing our properties. This says a power to a power. We need to take care of that first, and same down here. So we need to take 3 times 3/4. So if you need to on your calculator, take 3 times 3 divided by 4. I get 2.25, math, convert it to a fraction, I get 9/4. So this stays as 2 to the 3/4 times 2 to the 9/4 over, down here I have to take 2 times 3/4, and if I take 2 times 3/4 and convert it to a fraction, I get 3/2. Okay, so I made sure that I took my power raised to a power. Now I can probably do all of this in one step. I'm going to keep my base. I'm going to add these two together, and then I'm going to subtract this one, because when you're multiplying, you add. I'll get my answer, and then when I'm dividing, I have to subtract. So on my calculator, I'm going to take 3 divided by 4 plus 9 divided by 4. I'll hit enter to get my answer. So that was 2 to the 3rd power on top. But if I have 2 to the 3rd divided by 2 to the 3/2, now I have to subtract 3 divided by 2 and math convert it to a fraction. So after doing that, taking 3/4, I'm adding my exponents together, 3/4 plus 9/4. Got an answer to that, so 2 to the 3rd power, what was on top. So then when I'm dividing, I have to take 3 minus 3/2 to get my exponent. So 2 to the 3/2 power. And again, we can leave it as exponential. And then 6 is a little bit easier because that one has a base of 9. Now I could have got those all as bases of 3, but I don't need to as long as they're all 9s. So in the numerator, I can keep the base, I can add the exponents. So I can take 5/4, 5 divided by 4, plus 1 divided by 4. I get math, convert to fraction. I get 9 to the 3/2. And now I have to make sure that I'm subtracting. So I keep my base of 9. I take 3/2 minus 4/3. So I took my answer 3/2, subtract 4/3. Again, math, convert it to a fraction. I get 9 to the 1/6. So that would be the 6th root of 9 if I had to put it in radical. All right, so all of these are just making sure you can use the properties of exponents, but you just have to make sure that you're working with the fractions.